All right, everyone. Welcome back to another 5-Minute Frenzy. I'm your host, Ryan Gopinski, and today we'll be introducing the concept of blood gas analysis. This is just the tip of the proverbial iceberg, but it's a great place to start if this is not a skill that you do on a regular basis. Today we'll be discussing the 5-Minute Frenzy 5-step process to ABG analysis. So where do we begin? Well, as Maria sings in The Sound of Music, let's start at the very beginning. It's a very good place to start. We cannot discuss aberrancy without first knowing what normal is, right? So this chart depicts the normal ranges for each of the values measured on a typical arterial blood gas. For the purpose of this presentation, we're only going to be concerned with the first three lines: pH, bicarbonate, and carbon dioxide. The normal pH, 7.35 to 7.45. The normal bicarbonate, 22 to 26 milliequivalents per liter. And the normal carbon dioxide, 35 to 45 millimeters of mercury. The first step in analyzing an arterial blood gas is to determine if the patient's pH is normal or abnormal. And if it's abnormal, to determine whether the patient is acidotic or alkalotic. Keep in mind that pH is measured on a negative logarithmic scale that calculates the concentration of hydrogen ions in a liquid. That is, the more hydrogen ions equals a lower pH, and fewer hydrogen ions equals a higher pH. Also, because it's a logarithmic scale, small changes in pH reflect much greater changes in hydrogen ion concentration. A pH of 4.0 is 10 times more acidic than a pH of 5.0 and 100 times more acidic than a pH of 6.0. Our bodies live in a very narrow margin on the pH scale. A normal pH for us is between 7.35 and 7.45. If the pH falls below 7.35, we call that acidotic. And if the pH is more than 7.45, we call that alkalotic. The next two steps in the analysis are done to determine why the patient is acidotic or alkalotic. And there's two possibilities. It can either be a respiratory problem or a metabolic problem. So let's take a look at both of those now. Step number 2 in reading an ABG is to analyze the bicarbonate ion concentration. This is labeled as HCO3 on an ABG printout and is typically the third or fourth value from the top. If you remember, the normal values for bicarbonate are 22 to 26 milliequivalents per liter. Bicarbonate is the body's way of neutralizing acid, so therefore the more bicarbonate present, the more acid will be neutralized, and vice versa. A bicarbonate less than 22 will cause the patient to be acidotic, and a bicarb of more than 26 will cause the patient to be alkalotic. A derangement in the concentration of bicarbonate ion is a metabolic problem. If we examine the carbonic buffer system for just a second, you will see that as the level of carbon dioxide in the blood increases, the body converts it to carbonic acid and then eventually into free hydrogen ions. As the number of free hydrogen ions increases, the pH decreases and the body becomes more acidic. So for that reason, you'll notice that this illustration is the opposite of the last two. As carbon dioxide increases, the body becomes more acidic, and the opposite holds true. If you were to hyperventilate, you would blow off too much carbon dioxide and raise the pH of the body, and thus become alkalotic. A derangement in the concentration of carbon dioxide is a respiratory problem. The next step is to determine whether the patient's issue is respiratory or metabolic in nature, and to do that we use the mnemonic ROME, R-O-M-E, respiratory opposite, metabolic equal. What that means is that if I have a patient with a pH that's greater than 7.45 and a CO2 that's less than 35, then this patient is in respiratory alkalosis. If I have a patient with a pH of less than 7.35 and a bicarbonate less than 22, then this patient is in a metabolic acidosis. The last step is to determine compensation. Okay, not that type of compensation. As you know, our bodies hate to be outside of the homeostatic range and will do whatever is necessary to get back to what it likes. The respiratory system and the metabolic system work hand in hand to keep the body in that narrow window that I mentioned earlier. So when there's a problem with one of those two systems, the other one can pick up some of the slack. This does not happen instantaneously, so you may or may not see compensation on your patient's ABGs. For example, if you determine that your patient is in respiratory acidosis because the pH is low and the CO2 is high, and the bicarbonate is also elevated, it is assumed that the body is trying to create additional bicarbonate in an attempt to neutralize that extra acid. Thus, we call this a compensated respiratory acidosis. You may hear the terms partially compensated versus fully compensated, and what that is referring to is whether or not the pH has returned to the normal range. But for the purposes of this presentation, we will consider the derangement compensated if the body has initiated a change in the alternate system. Okay, let's take a look at a few examples and see how you do. All right, for this patient, the pH is low, the carbon dioxide is high, and the bicarbonate is normal. This is a uncompensated respiratory acidosis. This patient, the pH is high, the carbon dioxide is normal, and the bicarbonate is high. This is an uncompensated metabolic alkalosis. This patient, the pH is low, the carbon dioxide is low, and the bicarbonate is low. Now, remember I said always look at the bicarbonate first. So if the pH is low and the bicarbonate is low, then this is a metabolic problem. The carbon dioxide is also low because the body's trying to compensate for the metabolic problem. This is a compensated metabolic acidosis. This patient has a low pH, a high carbon dioxide, and a normal bicarbonate. This is an uncompensated respiratory acidosis. This patient has a low pH, a high carbon dioxide, and a high bicarbonate. The bicarbonate does not change in the same direction as the pH. So now I'm looking at the carbon dioxide. The carbon dioxide changes in the opposite direction as the pH, so this is a respiratory problem. This is a compensated respiratory acidosis. Guys, that's all I have for you today. I hope that this was helpful. There are plenty of ABG interpretation worksheets available on Google if you need some more practice. Be on the lookout for Part 2, Advanced ABG Interpretation, in the near future, where we will break down and discuss differentials for each of the derangements. In the meantime, feel free to drop me a line on Twitter at RyanGapinski2, and I will talk to you again real soon.